The Qingshankou Formation in the Gulong-Qingshankou of the Songliao Basin in China has rich shale deposits that contain about 15.1 billion tons of pure shale oil, making it an important reservoir in the Daqing Oilfield. Recent studies have found that the Gulong-Qingshankou repository has a source-reservoir ratio of over 90% and a distinct network of nanoscale pores and fissures filled with solid bitumen. Exploring this further, a new study published in Earth Science Frontiers and conducted by Dr. Wenyuan He from Daqing Oilfield Company Limited sheds light on the reservoir space and in situ accumulation of shale oil in the Gulong-Qingshankou reservoir. Using electron microscopy, Dr. He investigated the petrological and microfabric properties of the Gulong Shale. He found that the Gulong Shale primarily comprises of layers of clay with well-developed nanopores and fissures. Within these nanopores, the clay particles adsorbed about 53.6% of organic matter on average to create organic clay aggregates with high carbon and hydrogen contents. This organic clay was the main source for forming hydrocarbons. During hydrocarbon generation, almost 87% of the organic matter was consumed, leaving behind empty nanopores and fissures. Since the hydrocarbons produced were in the form of liquid bitumen and oil, they occupied these empty nanospaces. The closed shape of the nanopores and a high capillary resistance prevented any movements of the hydrocarbons, trapping them inside the rocks to eventually solidify into solid bitumen or asphalt. This basically indicates that the hydrocarbons found inside the Gulong-Qingshankou reservoir were both produced and stored in situ, which also explains the high source-reservoir ratio. These findings add to the understanding about the formation and unique petrofabric and spatial characteristics of the Gulong-Qingshankou reservoir. This can potentially enable the advancement of shale oil exploration and development in the region.